Hi guys, so here we're starting out section 4 of Unit 5 with oxidation numbers. You'll need your notes as well as your periodic table. So here we're going to talk about atoms and compounds, oxidation numbers, and rules for assigning oxidation numbers. So this slide is review. Atoms are neutral because the number of protons are equal to the number of electrons. Protons are positive, electrons are negative. So when you have the same number of positive charges and negative charges, overall it's going to be 0 or neutral. In compounds, however, atoms will gain or lose electrons or share electrons. So their electron numbers may not always stay the same. In ionic compounds, we know that atoms will gain or lose electrons to form those ions. In covalent compounds, we know that those atoms will share electrons unevenly. We call that polar. So even though, like if you have a carbon and an oxygen, they are sharing electrons, but they're not going to be sharing those electrons evenly. If you need help with polar versus nonpolar, that's over in Unit 2. So oxidation numbers are pretty much the charges that are left when electrons are gained or lost or shared unevenly in a chemical reaction. So as a reminder, since protons are positive, electrons are negative, we're only going to be dealing with the electrons here. The electron number is the only thing that changes. The protons will stay the same. So if an atom loses electrons, that means that the proton number, again, is still the same, but now overall there's going to be more protons than there are electrons than there were before. Hence why it has a positive charge. When electrons are gained, again, that proton number stays the same, but now there's going to be more electrons. So it's going to be the charge is going to be overall negative. So what I have down here is just from your periodic table. It's just the key from it. And we know if I have asked you what the oxidation number is or what the charge is, you take a look at the upper right-hand corner. Before, for non-metals especially, I've told you, hey, just take the top of the top charge. We'll deal with the other charges later. Well, now is later, so we're actually going to be figuring out which one of those charges we're going to pick for each of the atoms in a compound. So here's some rules for assigning oxidation numbers. You do need to know these rules, so highlight these, circle them, whatever you need to do to make sure that you've got these. The first rule is pretty self-explanatory. If an element's by themselves, they're not going to be sharing or transferring any electrons, so they're going to be neutral. They're going to have a charge of 0. So here we have two different chemical equations, and we're going to figure out what the charges are for at least some of the elements in these equations. So the first thing we have here is O2 plus 2H2 produces 2H2O. So here the O2 is all by itself. It's not attached to anything else, so its charge is going to be 0. Same thing with this H2. It's not attached to any other element, so it's going to be 0 as well. On the right-hand side, the 2H2O, we need special rules for these, and we'll get to those in just a bit, because these are going to be compounds, so we can't really quite put those rules in just yet. Now let's take a look at the second example. Here we have Zn, and what I want to emphasize is the fact that it's solid. It's going to be overall neutral. It's going to be just a metal by itself, so again, that's 0. We have HClAq. We don't know what that is quite yet. I'm sure before you kind of remember some of the other rules, but we'll go back through it again today. Same thing with that ZnCl2. There's two different elements there, so we can't quite put the rules in just yet. We will in just a few slides, though. And all the way on the right, we have H2 all by itself as a gas, so that is going to be 0. So again, any element by themselves have an oxidation number of 0. So now we're going to deal with the other rules to figure out what those compounds could be. So for the second one, elements in group 1 have an oxidation number of +1, and we've seen this before as well. So if it's a group 1, with the exception of hydrogen, so we'll deal with hydrogen later, any of those core group 1s are going to be a +1 charge. And before I've let you kind of look at your periodic table to figure that out, now you need to know it. And the second one is, the next one is elements in group 2 have an oxidation number of +2. Again, group 2, +2 charge. Those are some of the basic rules here. Another rule is that fluorine is always going to be -1. Fluorine's extremely electronegative. It's going to take on electrons to fulfill the outer shell, to fulfill the octet rule. So its charge is always going to be -1. Okay, so when hydrogen's combined with a nonmetal, it's going to be +1, and when it's combined with a metal, it's going to be -1. So we have two examples here. We have first one, lithium hydride. So lithium is going to be a metal, so that therefore the hydrogen is going to be a -1 charge. In fact, we know lithium. Lithium is a group 1 metal, so it's going to be a +1 charge. So when you have that +1 and -1, overall it's going to be neutral and zeros, hence why the overall charge of lithium hydride is 0. But individually, the lithium is +1, the hydrogen is -1. The next example here has hydrogen fluoride. So we have H and F. When we knew before, hydrogen is always going to be -1, so we'll use that. And when hydrogen's with a nonmetal, it's going to be a +1. So when we have a +1 charge and a -1 charge, that all ends up being equal to 0. Hence why that hydrogen fluoride is overall 0. But specifically, or in the actual equation, hydrogen is +1, fluorine is -1. The next rule deals with oxygen. So oxygen has a few little funny rules. When oxygen's with fluorine, it's going to be a it's going to be a +2 charge. Make sure you fix that in there. So when oxygen's with fluorine, it's a +2 charge. So here we have 1 oxygen and 2 fluorines. So let me just put this off to the side. I have 1 oxygen, and it's with fluorine, so it's going to be a +2 charge. Let's add that to fluorine. We know that there's 2 fluorines here, and each one of them will be a -1 charge. So if we have a 1 times 2, of course, is 2, plus a -2 gives us an overall charge of 0. Hence why this entire compound is overall 0, but the oxygen is going to be a +2, and the fluorine is going to be a -1. The next rule for oxygen is as a peroxide. So peroxides from Table E, you've seen hydrogen peroxide. In fact, that's an example down here. It is O2 minus 2. So we're used to each oxygen being -2, but in this case, the peroxide, there's going to be 2 of them in there. So let's take a look at the hydrogen peroxide down here. We have 2 hydrogens. Since hydrogen's with a nonmetal, we know that hydrogen's going to be a +2 charge. Let's erase that and do that over again. There's 2 hydrogens, each one are going to be a +2 charge. Now, yes, it is O2, so there's actually just one O2 listed right here. And that's where it gets a little funny, don't worry about it. That's going to be a -2 charge. So here we have a +2 and a -2. Overall, that should be equal to 0, and that's good. So when we write this out, H is +1, and we write out the full O2 minus 2 as its charge. Now keep in mind, oxygen's not a Hunkelberg at this point, because it is combined with another element. The last rule, you've known this before, oxygen's -2 with everything else besides fluorine or acting as a peroxide. This rule here, the sum of all elements in a polyatomic ion is equal to the ion's charge. And we can take a look at Table E to help us out with this. So we have MnO4 minus 2. So overall, this is going to be a -2 charge. We have a rule for oxygen, but we don't have a rule for manganese yet. So that's going to be our unknown. That's going to be our X. So we have 1 manganese times the unknown X, plus there's 4 oxygens, and each of them are a -2 charge. Overall, that whole thing is equal or set equal to -2. So now you have to solve for X. So when you do, you have X is equal to, X plus -8 is equal to -2. So your X should be equal to +6. So the manganese, and we'll write this out, Mn is +6, the O is -2. And we have down here carbonate, so CO3 minus 2. C has several different oxidation numbers, so we don't have a specific rule for that, but we'll go ahead and set that equal to whatever the charge is. So we have an X for the charge for the carbon. We don't know what that is yet. We know that there's 3 oxygens, each of which are a -2 charge, and that's set equal to -2 because that's the charge listed right there. So we have X plus -6 is equal to -2. So in this case, your carbon has a charge of +4. So again, we'll write this off to the side. C is plus 4, oxygen is negative 2. So we can write them out horizontally or vertically, either one works. Alright, and this little rule, the sum of all elements in a compound is equal to 0. So we know that hydrogen here, we have hydrogen and we have SO4. SO4 is from table E, so that's a sulfate. It overall has a negative 2 charge. That means that that hydrogen is a plus 2. So your H is hydrogen is a plus 1 charge, but there's 2 of them. So I know that there's 2 hydrogens, each of which are a plus 1 charge. Actually, that might confuse you there. So this is for the hydrogen. The sulfur, we don't know what that is yet, what its charge is yet, but we know that there's only 1 sulfur. We'll set its charge as 0, so that's sulfur. And the oxygen, there's 4 oxygen, each of which are a negative 2. And that's all set equal to 0 because the compound is equal to 0. So for the hydrogen, we have 2 plus an X minus 8 is equal to 0. So go ahead and combine like terms and solve for X. So here, you should have X is equal to a 6. And of course, we can always double check that. We have 2 hydrogens, or pretty much put that 6 in and solve, make sure that the charge is 0. So let's put this into action. Here we have 4 Fe solid plus 3O2 gas produces 2 Fe2O3. So we know that Fe here is going to be a charge of 0 because it's all by itself. Same thing with the oxygen. And don't worry about the coefficients in this case. The coefficients are just to help you figure out what the moles are. We just want to deal with the core of the compound. So right now, we know that Fe can have several oxidation numbers, but we know that there's 2 of them, so that's our unknown. For oxygen, we know that there's 3 oxygens, each of which have a negative 2 charge, and this is a compound, so we'll set it equal to 0. So you have 2x plus a negative 6 is equal to 0. So we have 2x is equal to 6, x is equal to 3. So each iron is a plus 3 charge, and each oxygen is a negative 2 charge. So here we can see that if we went from iron on the left-hand side to iron on the right-hand side, it went from a 0 to a plus 3 charge. If we look at the oxygen, it went from a 0 to a negative 2. So at some point, electrons must have been transferred between the iron and the oxygen to give us that change in overall charge. So the Fe went from 0 to plus 3, and the oxygen went from 0 to negative 2. Alright, so to summarize, just make sure you know those basic rules and your basic math operations to solve for each element or compound. Have a great day, guys.